If you haven't seen these, this is called a piecewise function. And if we have time, we'll do it second semester. I'm not sure we will, but you will run into these, those of you going into later on math. So piecewise just means we're defining the function. So this is still just one function, f of x, but it's defined now in three pieces. And then the second part is where each of those functions take place. So like anywhere left of -5, it's going to look like the left arm of a parabola. And then between -5 and 4, it's going to look like a line with the downhill slope. And so if I start sketching this, like over here, it's going to be like the left arm of a parabola, like I said. And then between -5 and 4, it's going to have some kind of downhill slope line, like that. And then after 4, it's the square root function, which is something like that. So it's piecewise. It just means that it's defined in pieces and picks up where the other leaves off, that kind of thing. Anyway, remember this just means function evaluation. So what is the function's value when x is -5? That's all this is asking, okay? So we just go up here and we say, look, this says x and then or equal to -5. So that means we use this middle piece. So f of -5 is just 1 minus -5, which is 6. Okay, and then b, f of -7, that -7 falls in this first piece. It's less than -5. So that would be -7 and the whole thing squared, which is 49. Okay, f of 4. Where does 4 fall in the pieces? First, second, or third? First piece, second piece, or third piece? Third piece, right? We see a 4 here, but it's not or equal to. So it's just that one. And so this would be 6 times 4 plus 1, whole thing square rooted, which is the square root of 30. Roughly what? It's like 5.5, right? Roughly. Okay, and then 9, obviously greater than 4. Okay, thank you. And so we still plug it in the same one, 6 times 9 plus 1. And that's the square root of 60. And what is that roughly? Well, it's definitely not bigger than 49, right? Yeah, it's way smaller than 49. So piecewise functions are cool. If you plan to be somebody taking calculus someday, we do a lot with them. And, well, a fair bit. Pre-calc 2, I think, does that. But they're pretty straightforward. Like pick wherever your x value is in the, these are called intervals, right? In the interval, use that piece. Graphing them can be a little bit of a pain. Number 2, which line is perpendicular? So first thing we have to do is find the slope. So I've done that already. Remember slope, y2 minus y1 over x2 minus x1. It's just change in y over change in x, that's all. We plug that in. -3 plus 3 is 0, so the whole thing is 0. What kind of line has a slope of 0? What kind of line has a slope of 0? Okay. So we know that perpendicular to a horizontal is a vertical. We just need to go in here and decide which of these is vertical. And you guys should know that. We've done this plenty. It's the same as like an axis of symmetry line, which is what? X equals 7. Okay, that's the vertical line. That's the vertical line. All right, next, range. I will say you better be familiar with this one, right? We've done this a lot. Range is what? Just like, what does it mean?
It's the y value.
Yep, the y values that the function outputs from bottom up, right? Bottom up. Does it matter that we have a gap right there? No, because why? Well, okay, let's say it this way. It doesn't matter in domain. It does matter in the range, though, right? Because, let's zoom in. Because we are not actually we're taking the values between those 2 points we're not using. The function's not putting them out. It skips them in the vertical direction, not in the horizontal. Okay? So it doesn't matter for the domain, but for the range it does. That means we're going to have to pick one of these kind. Which one is it? D. Good job. And then number 4. The wording on this is kind of dumb. So it's the 68 nickels and quarters. It means that it's the total. The way I first read it, and we were talking up here, the way I first read it, it's 68 nickels. That's what I thought. That's what it reads. But really it should be like this. N plus Q equals 68 for a total coin count of 68. And then the total money would be 0.05 N plus 0.25 Q equals 1160. Everybody good on that? Like 0.05 is 5 cents, 0.25 is 25 cents. And then how do you solve this? We actually did a fair bit of this as well. Guys, this is a system of 2 equations with 2 variables, right? What are your methods or options for solving it? What was it? Yeah, we have to do something first. I think you're talking about substitution, maybe? And?
I don't remember doing much this morning, but you would have to subtract these at magnitude in the first one. Or do you want the variables?
Oh, it's okay, so that's still substitution. It's interesting because we did mostly elimination, right? Where we scaled up and matched the coefficients and then put them together. And yet people are seeing this one as maybe easier to do by substitution, which is fine. I just think it's kind of cool that you're, at least I think this is what's happening, that you're seeing that this would be easier to do something like this time, right? And then take that and substitute it in for N right there. Versus trying to scale these and make the coefficients the same. I don't know. Anyway, once you do that, you get this. And now we have our variables. The only variable in the equation is Q. Someone with the calculator do 0.05 times 68, please. 0.05 times 68. Thank you. Okay, and then from here, it's just a linear equation. I hope this looks pretty easy. You are in Algebra 2 after all. So what does this become? 0.3Q on the left. Subtract your 340. And we get 820, I think.
Yeah.
I know I'm not writing very neatly. Sorry about that. Okay, how many quarters are there then? Just divide that. What's 8.2 divided by 0.3? What was it?
27.3.
What? Is that what you said?
No, 27.
Oh, 27. Still. Oh, does anybody see my error? See if you can spot it. I'll start filling stuff in that is correct. That's that's all. So my error is here. Error analysis is really good. That's why I'm having you do it. Anybody see it?
You wrote the wrong side?
Yeah, it should be minus 0.05Q. That was probably because I was hurrying and writing ugly. So, those of you who don't write neatly, there's a good reason to do that. All right, now that one's easy. So it's 41 quarters. Yeah, that's because I wrote it ugly. That's what I'm saying. Sorry about that. 41 quarters. How'd you do on that? You cooked, huh? Okay.
I got 32.8.
Well, that's because we read it wrong, and that's not our fault. All right, check your homework. Grab that, please. By the way, I'm hoping with this new unit that I'm going to see kind of an uptick in the homework effort because going into this last test and last unit, it was pretty low. I think I was having maybe 10 or 12 of you consistently do homework. So I'm a little over halfway through grading your tests. That should be, I definitely will have them to you by Thursday. This group is starting to talk too much every day. Chill. Anyway, if the scores are lower than I'm expecting them to be on this, I'm going to attribute some of that to lack of practice, right? You got to do your homework to get the practice for yourself.
Was it not taking the odd questions?
Yeah, but I have all of them on here. So it was just odds, but go ahead and check those, please. And we're going to do 21 for sure. Any others that you'd like me to do? By the way, the little picture is not necessary. It's just an illustration of the end behavior. Yeah.
I'm assuming it doesn't matter, but the way you write it is yesterday you were writing the line and say,
Writing what?
so you can step while.
Oh, I see, like this instead of here.
Yeah.
Yeah, that's okay.
Because
It kind of depends on the room, but yeah, that's okay. Okay, next section.
What inspired you to be a math teacher? Like, how did you just wake up one? Sorry, how did you just wake up one day and decide, yes, I want to do this?
I absolutely didn't do that, actually. It was quite a journey, to be honest.
Because I don't think I can wake up every day, come here early in the morning, and do this. I'm just saying.
I like math a lot. But I didn't wake up one day and think I'm going to be a math teacher. All right, next section. Guys, on these ones with the pictures, note that I didn't say a specific degree on these. I just said odd or even and then positive or negative. Because we're not trying to figure out the specifics, not yet. Here pretty soon we'll be able to say that, hey, this has 4 terms. So it must be a 5th degree polynomial. We'll be able to say that, or at least a minimum of 5th degree. But we're not there yet. We might get there today. Okay, next page. Okay, again, I told you yesterday that all that matters on these kind is that leading term. The rest of it doesn't address the question. So as long as yours matches the sign of the lead coefficient and the degree, then you're good. Okay, 19, same thing. Yours does not have to look just like mine. There's infinite different ways to draw that. You need to make sure your end behavior is opposite and that the right arm points up, left arm points down. Otherwise, it's flexible. All right, 21. Let's go look at that one. It says write an equation for a translation of g that has no x-intercepts. Translation means what? Yeah, like moving it either sideways or up or down, okay? Now, if you look at 20, it might help enlighten what we're doing with 21. Is there a way I can move the graph in 20 so that it doesn't have x-intercepts?
Yes.
Yeah, like if we do what? We just have to shift it so that this very bottom part is now somewhere like that instead, right? So that it goes up here and it never crosses the x-axis. That's the idea there. Okay? We could do a better job graphing it, I guess. So if we could move it up there, it won't have any x-intercepts. So there's lots of ways to do that. You could say plus 100 and it would shift it up, right? It doesn't have to be a specific value, just enough to get it up there. Now, the next one says, is there a way to do that with an odd degree? That's really what this is asking. And there's not, right? Because these two ends will always go to infinity. There's no way to move it. We could move it a million in either direction. It's still going to keep going and cross the x-axis at least once. Okay? So there is not a way to do that. How'd you do on this overall? Okay? Good. Seeing thumbs up, thumbs sideways, but we're getting there. I want you to take, what's a good one of these? Let's do this one. And let's go write this in your notes as a way to illustrate how to do those kind. So I think hopefully at this point, if I give you a polynomial in standard form, I'm hoping that you're pretty solid on being able to tell me the degree. That was a large part of your homework and what we did yesterday. But this is factored form. And you will work with factored form some in this unit. And do you need me to zoom it? In factored form, it's not immediately obvious what the degree is overall, but it's actually pretty easy to figure out. I'm just kind of making sure everybody has it written. Okay, so here's what we do. What is the degree? We know we're looking for the power of x, right? The highest power of x. So we're just going to add the exponents from each factor. So this is x cubed. Let me write an arrow real quick. That one is x cubed. This one is x what? The second one. X squared. This one is x into the first power. If we don't have an actual exponent, it's to the first power. Okay, so if we add the exponents, what do we get? X to the sixth. So this is a sixth degree. Now, is there going to be, if we expand this out, there's going to be lots of other terms, right? Like could be fifth, fourth, third, second, first. But again, all we care about for degree is that highest power. And so that's just going to be peeling the front term off of each one. And like this one, if we expand it out, would be x squared minus 4x plus 4. All we care about is the x squared. And same here, all we care about is the x on that one. So quick other example. Let's say f of x. I will tell you I like f of x better than y, so just keep an eye out for that. Let's do 2x plus 1 squared and call it good there. Okay. So what's our degree? Well, I have an x to the 4th from the first one. How about the next one? Okay, I have it's technically a negative x to the 3rd. If we were asked about the sign of the lead coefficient, that would be important. And then I have a x to the squared. And notice I'm not putting signs in between here. Like, in fact, we could even do this, put parentheses, because we're not adding or subtracting the x's. It's just the exponents that we care about for degree. Okay, so 4 plus 3 plus 2 is 9, so 9th degree. Now on your sheet, it tells you to actually verify that, which isn't super fun, I'll be honest. So grab your sheet and let's do one of these together. We're going to learn more about this in the next section, so I don't want to do it all now. Basically, all it means is distribute. So in this first one, it would be x cubed, and then x minus 2 times x minus 2 times x plus 1. Now, when it says verify, it wants us to actually multiply all this out so we see the 6th degree polynomial. How many of these can we do at a time? Like multiply at a time? Do 2 at a time. Okay, so maybe like those first 2, and you get, what is x cubed times x? X to the 4th minus 2x cubed. Okay, now make that a group and bring down the next piece. And then do those 2 as the next group. What's x to the 4th times x? So this will be x to the 5th. Minus 2x to the 4th, and then we got to do the other term, minus 2x to the 4th plus 4x cubed. Okay, and then do you see those like terms in the middle? They don't cancel. Sometimes they might, but not in this case. Go ahead and combine those like terms before you go start multiplying again. Okay, and here's what I mean. This would be x to the 5th minus 4x to the 4th plus 4x cubed. Put that in parentheses and now bring down the next one. And do this all over again. Okay, so now we've got to distribute. In fact, I'm just going to keep working here. Sorry, you don't have that option. Too bad you're not cool like me. Just kidding. All right, so now we got to do this. This is going to be a lot of terms, right? So x to the 5th times x is what? X to the 6th, okay, plus x to the 5th. Now we got to do it with the 4. So minus 4x to the 5th minus 4x to the fourth. Now we got to do it with the next one. So plus 4x to the fourth plus 4x cubed. And now we go combine like terms, if there are some. And we do. We have the x to the fifths right here. And so we have x to the sixth. What's x to the fifth minus 4x to the fifth? Negative 3x to the fifth. Good. Okay, and then we have our 2x to the fourth terms. What do they do? Yeah, they cancel. Sweet. Okay, and then we have our plus 4x cubed term. And so that's what, I mean, now we obviously see that it's a 6th degree polynomial, but also we see the whole thing. It's a little bit of a pain. Okay.
At the front part, before like the last whole part, could you not just do x plus 1 and then distribute that to the bigger one?
Yeah, either way. She's asking this, guys, could we distribute the x and the 1 on? Yeah, that would be fine. And it would be the same as that, Sophia. Like either way, you'll get the same thing. So why don't you try the other one, the last one on that page, please? This one. Do the whole problem, like what is the degree, and then prove it. I'll give you, what, 30 seconds? I'll give you a few minutes on that.
Do you have another copy of those worksheets?
Yeah, you can take that one.
No?
Right there.
Okay, thank you.
Teach you, right? So no, I definitely don't. That's right. Good job, Brendan. I want you to succeed in life. In life.
Yeah. He literally just said he's excited to not have this class because of you.
Because
Yeah, you should.
I'm excited to not have this
because of you?
Yeah. He was like, because of you.
Oh, jeez.
See, he's nice.
Tomorrow, you mean?
Yeah, tomorrow, because we both have release first period, so I was like, I'm excited to not have this class, so I get to sleep in.
Have you not?
And I need to like call the ambulance.
Yeah.
Okay.
Having a mental breakdown.
All right, first we see x to the first, x to the first, and x to the second. So this we know is a 4th degree. Right, just add up the exponents, so 4th degree. So if our proof doesn't match that, obviously we know something went wrong. Okay, big idea here. When you see a binomial squared, the x minus 1 squared means x minus 1 times x minus 1. It's not just x squared plus 1. So make sure you write out both. And then we have our x plus 3 and our x. So just do 2 at a time. I would start there, x squared plus 3x. Bring down an x minus 1. Okay, now distribute just the usual. And we'll get x cubed minus x squared plus 3x squared minus 3x from that. Again, combine your like terms in the middle before you multiply again because it will just make less terms. So this becomes 2x squared. Okay, bring down the next x minus 1 and go ahead and distribute again. And Sophia suggested going this way with it, which is fine. We'll get x to the 4th, x times x cubed, and then we'll get plus 2x cubed minus 3x squared. So that's this way. And then do the same thing with the 1 all the way across. So then you get minus x cubed minus 2x squared plus 3x. Okay, and then here's a little tip on combining your like terms. Since these are separated, like the x cubes are separated, once you've dealt with them, cross them off. So here's what I mean. We just have the 1 x to the 4th. Now we have 2x cubed minus x cubed. So that's just x cubed. And then since I dealt with them, I'm going to cross them off my list. So I know I don't have to do it twice. Okay, then I see negative 3x squared and negative 2x squared. So that's negative 5x squared. Now I've done those, get them off the list, and then plus 3x at the end. And that proves that we had a fourth degree polynomial. How'd you do?
So, we get from the limits of my
You're good.
I totally thought that I was subtracting that from
Okay, can you stay and I'll show you?
this.
All right, homework for Thursday. Do 22 and 25. 22 and 25. And number 8 and number 6. I know I went kind of backwards. 6, 8, 22, 25. I'll post it. 6, 8, 22, 25 for Thursday. Is that okay?